and how it integrates with other systems. So a little bit of background about myself. My name's Rohit Bakshi. Nice to meet everyone. I'm a product manager at Hortonworks. Hortonworks is a company that actually was formed to do a lot of development and promotion and services and support of Apache Hadoop. Hadoop is an open source software solution. I'll talk more about that as we get into the further slides. And Hortonworks is the company backing it, building it, developing it. And we actually work very closely with Microsoft, as I'll get into later as well, to bring Hadoop to Windows and to make it work as part of HDInsight service. So I started off my career actually as an application developer, as a developer of this really cool application that we created that did multi-dimensional OLAP analysis for marketing analytics. And so this was done with an architecture where we had a SQL Server backend, and we had I think a Java application, web application, and then we built some custom UI. And we were doing queue-based OLAP analysis of tying sales information to marketing spend. And so this was years ago, building out this data analysis application where we're continuously processing data and updating these UIs to show people and help them forecast if they change different marketing drivers, how is it going to impact the end sales? So it was a really fun project and kind of got me introduced to the whole data analysis and application development on top of data platforms space. And then after that, I went and, as part of Accenture, did a lot of consulting around doing advanced data analysis work, which basically meant I focused on big data solutions. And this was, again, years ago where it was just starting. And so went to talk to a lot of clients, understood what kind of challenges they had, understood what challenges they had with their ETL infrastructure, with storing lots of information coming in, and then helping them understand how to use architectures with some of these newer technologies to solve some of those problems. So we'll go through some of the use cases and go through some of the different ways to apply this technology to those problems. And then after that, I joined Hortonworks and now work on parts of the Hadoop ecosystem, and actually am responsible for our product on Windows, the Hortonworks data platform on Windows, and we'll talk more about that. As we go through this, I don't know what other speakers are doing, but we could, if you have questions, raise your hand, and we can answer them as they come up. And then I'll leave some time at the end as well for questions. So here's what we'll do. We'll first start off and kind of lay the land of why Hadoop. What is the problem out there? What are we seeing when we talk to clients and enterprise companies? And then talk about why Hadoop's a good fit for it. We'll then talk about specifically what is Hadoop on Windows. Hadoop didn't really start off on Windows. It's a newer development. So we'll talk a bit more about that. How it fits in the Microsoft Big Data ecosystem, kind of the vision that was laid out at the keynote and what Microsoft's doing. How does Hadoop fit into all of that? And then talk about the actual platform underneath the covers. So we'll go through all the components there. And I really want to focus on showing how it fits in with your existing enterprise architectures, integration with existing Microsoft tool sets. And that's what makes it a very powerful application. Then I'll have a short demo, show some of the features, and then keep some time for questions and answers. So let's start with why Hadoop. When we think of why Hadoop, I like to start with thinking about what's happening with our data and the data out in the enterprise ecosystem that's causing us to look at this completely new and different form of storing and processing information. So let's kind of go back and think about the application and how data applications have evolved over time. So starting off, they have this graph here of volume on your y-axis and variety and complexity and types of information on your x-axis. We started off with ERP many years ago, where basically you had a defined amount of information, you had a defined type of information, you knew you were storing information about your transactions, about purchases, about who bought your products, and you had these systems that were storing that limited amount of information and reporting on it, giving you insights as to how many products were sold, giving you the state of your business through that application, through that data. Over time, we started looking, and as our architectures grew and as data management systems grew, we started looking at doing things in the CRM space, for example, where now you're not just looking at a limited set of purchase history and payment records, you're actually looking at studying all your customers, storing information about your customers, doing some advanced analytics like segmentation, figuring out how different segments of customers work with and kind of which products they buy, which geographies they shop in, all this kind of more advanced analytics work. And in this kind of scenario, what this did to our data infrastructures was it now added more operational and analytical processing workload requirements on those data architectures. And so now you went to more powerful databases like SQL Server, where you were building cubes, you had dimensions, you had fact tables, you tied them together, you did things like OLAP analysis in memory or in the database, pushing queries down. And so the growth of the use cases to processing more data and trying to do more interesting things with it led to the growth of data architecture and the underlying database components. And then we went to a world where we saw the value in CRM, we saw the value in analyzing customers, analyzing transactions and interactions with your company. And then we said, great, I now know how to do analysis and create models that execute at aggregate segmentation, right? When I did this stuff with the marketing analytics application, we had to do models at the level of states or at the level of regions or zip codes. It was really hard to take that same processing and the same architecture and move it to something where we were looking at each and every individual transaction, each and every individual interaction, and run the model against that. The architecture just didn't scale. So as we go to a web world where we're now storing web logs, we're now storing very granular interactions with your business, the strain on the data architecture and the types of data platforms you have to use has challenged us to come up with these new forms of storing and processing information. And that's just the current state where we're doing this, and then that's really where scale-out infrastructures like Hadoop are coming into play. Now, as we keep going, and this is just the start, when people say the word big data a lot, and the way I look at big data is it's really a combination of a lot of your different types of data that's in the enterprise. There's transactions that have been there since the beginning of time, beginning of data analysis. There's interactions where now you're capturing and understanding and evaluating all your interactions with your customers. And then there's a third, observations. And what that means in the context of data in the enterprise is that these are not just interactions with your customer, but these are sensed events that are happening out there. So an example of that is, I live in California. In California, we have these smart meters. And I think they're being rolled out in other parts of the country as well. These smart meters are capturing information about your electricity usage. Every 15 minutes, you get, I think it's eight segments of information about power. I forgot what I studied in electrical engineering college, but there's different voltage and power usage and temperature, different sensors that is being captured every 15 minutes. Imagine doing this for millions of houses in that one area of the Bay Area of Northern California. All this is coming every single day, every 15 minutes. These aren't me going out and making interaction that directly works with my utility company. This is just the utility company keeping tabs on what is going on at an extremely granular level. And they need to store all that by regulation from the government, starting from the point that they start capturing this information. That's a huge, huge impact on their data architecture and the types of systems they need to store and process that information. And again, it's really the start, right? We're now at this point where it's not just utility companies, not just telecommunication companies capturing all mobile information or location information over time. But as we talk to clients, in almost every industry, there's a need to grow and store more and more information, as well as store increasing variety and complexity of information. So it's not just data that fits nicely into a relational model where you have some kind of structure, but it could be text files, XML, JSON, key values, all this information that's being captured where you don't really know how to process it yet, but you want to make sure you don't lose any of that information. And so that kind of pressure and that kind of growth is causing us as a community to really think about what we need to do with our data architectures, what kind of new systems are needed. And going forward, a lot of the new information that's being captured is that unstructured, semi-structured, multi-structured data. That's really what's growing, and that's really what businesses are seeing as a differentiator if they start capturing that information and storing it. And so that's causing us and Microsoft and other companies to really come together and build new types of data platforms and new types of data architectures to store this information. That's what's really exciting. So with that, we kind of set up the problem statement, right? Why do we care about this? What's going on in the enterprise? And here's where Apache Hadoop and the solution stack enters. Apache Hadoop is an open source software. And open source means basically, well, let me give you a bit of a history to understand why it's open source and where it started from. So Apache Hadoop is a technology platform that helps solve the problem of scalable storage and processing. Apache Hadoop was created and started at a lot of the web companies. So Yahoo was one of the original companies that put engineers and built out this data processing architecture. LinkedIn, Google, eBay, a lot of these other companies joined and helped build it out. And the way they did that was they did it all in the open source. So Yahoo didn't own any of this code. They didn't do it all in-house. It was all done in public as part of the Apache Foundation, because that enabled Yahoo to incorporate all these other companies, Microsoft, all these companies to come together and help build this out and use it themselves. Hortonworks, our company, was formed out of Yahoo. So a lot of the key engineers who built Hadoop from 2006 onwards, a few years ago, spun out and formed Hortonworks, and so now we're tasked with driving the projects forward and really building out Apache Hadoop to meet different types of enterprise use case analysis needs. And with that open source software, Yahoo actually used the Hadoop data platform to do a lot of their search indexing, to store a lot of their customer interactions up to the websites and serve up and do content optimization. And so the core of that was Hadoop. Hadoop being a scalable, at its bare bottoms, a scalable file system and processing layer. So now there's an open source software that can scale up horizontally to store all the information that you're capturing as an enterprise, do it in a cost-effective manner, and then provide a platform to do processing on top of that. And we'll talk a bit more detail about how that happens and why that works. So we talked about the problem statement. We talked about what Apache Hadoop is and how it is intended to solve the problem. Now, until a few years ago, Apache Hadoop and all its development only happened on a limited set of platforms. It only happened on the Linux platform. And so what we've done, and we work with Microsoft on this, is that we've taken the Hadoop stack and we've worked with them to make sure it runs natively on Windows. So now you, as a Windows Server, somebody who has Windows Server 2008 installed in their network, in their cluster, in their data center, can actually download and install Apache Hadoop and have that work natively with the same set of performance functionality that you get in other platforms. And so that's some of the exciting work that we've done with Microsoft. Now, how many of you have heard about HDInsight service, or HDInsight Azure? Okay. About half the room. So HDInsight is an offering from Microsoft that basically provides Hadoop as a service in Azure. And we work very closely with Microsoft to take Hadoop and make it run on Windows, and now it's available as HDInsight. And what powers HDInsight is the Hortonworks data platform at its core. So I'll go into this a bit more in the next slide. HDP, the Hortonworks data platform, is the set of open source Apache Hadoop components that come together to create the Hadoop platform. And we worked on that together with Microsoft. It's what powers HDInsight. And what that does is that it gives the Windows community an ability to use the same Hadoop distribution, the same Hadoop power and functionality that the web companies that eBay, Yahoo, and Google were all using. And it brings it to the entire set of Windows system administrators, developers. It really expands the ecosystem. So now you, as a .NET developer or somebody who uses System Center, can deploy and use and manage the Hadoop stack of applications on Windows Server. And so that core of components, the open source components that form the Hadoop distribution and part of HDInsight, is what Hortonworks Data Platform is. And when I think of the Hortonworks Data Platform, it's really a comprehensive set of components that provides everything you need to do from storing, processing, and analyzing information and data. So at its core is the distributed storage and processing. And then around it, what we've done is we made sure that the processing and that Hadoop core is redundant, it's secure, it works natively on Windows Server, and you also have the ability to do processing SQL-like queries, scripting, as well as management, all in the same platform. So what does this mean in a Microsoft Big Data ecosystem? So it's nice to always think of the vision first and then go into the details. So the vision here is that you want to have one end-to-end big data platform, one platform to store different types of information, be it relational, non-relational, be it logs coming in as non-relational data, be it streaming information from tweet streams or streaming information from sensors out there in the electricity network. Store all that information captured in one logical unit. So even though they'll have different components inside it, it's captured in one logical unit of a big data platform. And then within that same platform, provide the ability to analyze and process to different types of users. So users who are looking to discover data, your data scientists, your data analysts who want to look at raw data and understand what value it provides, or look for trends. Let your ETL developers analyze and develop applications against it. And all that analysis, make sure it connects with all the different tools that you're used to and comfortable with in terms of sharing that information, in terms of providing that end user UI, so Excel and all these different tools. So this one data platform through the core components, as well as through APIs, connects to the different tools that you use to extract value from this data platform. And with that vision in place, that's really where the set of components with the Microsoft ecosystem of tools and Hadoop really come together to provide and make that vision a reality. So when we look at Hadoop, the Hortonworks data platform for Windows, we look at SQL Server, Parallel Data Warehouse, it all comes together to make sure you can store both information coming from systems that are OLTP systems, RDBMS systems, news sources, web logs, emails, capture all the information in one logical place, and use the right tool for the right job or the right query, right? So the Hadoop is really good at storing unstructured and multi-structured data. SQL Server in the same platform will be able to store your relational data, your OLTP systems, your customer data. And no matter where the data is sitting in which system, there's seamless interoperability and movement between the two. So there's connectors that we have that will make sure you can move data in between Hadoop and SQL Server. And then your applications will be agnostic and won't necessarily be tied to one of these databases. They can operate against both. So your Excel, if you're a business analyst, can work against the Hortonworks data platform, Hadoop. It can also work against SQL Server. So you have these different tools, SSIS, Excel, Power Pivot, Power View, that all, because of the APIs around Hadoop and around SQL Server, can be used with the same data platform. So any questions so far? Both. Yeah, so there's connectors for both. So let me talk a bit about the right tool for the right usage, and this goes into a little bit of the architecture differences, right? So when you're thinking about why Hadoop and why Hadoop's helpful in extending the types of information you can store, it's good to think about the different architectures between a relational system and a Hadoop system. So at a high level, it's good to just think of the reason Hadoop exists is because we're doing these things that we've been doing at scale. So when it comes to a slightly smaller scale, traditional databases, EDWs, are a very good fit, enterprise data warehouses. When you go to the scale of you have to store lots of information on different machines, that's where a system like Hadoop comes in and becomes useful. How does it become useful? So let's think about loading and writing data. When you load data into SQL Server or into a relational database, you are prescribing a schema as you load it in. You're saying it fits into this table, with this set of columns, this index. And what that then means is that when you do your reads and you do your queries on top of that data, it's fast. It's indexed. It's compressed. It knows exactly how the data is laid out. Hadoop is almost the opposite. When you load data in, you're just loading in raw data. You're loading in files. You're loading in data sets. You're writing key values. You could load CSVs, but you're just loading files and data, raw data. And the value there is that you can capture all kinds of information and data in Hadoop. And then when you want to run queries and run processes on top of it, that's when you prescribe a schema. So you can have a flexible data layer where you have this raw data sitting in there, and you can have different types of schema put on it or prescribed to it. It's not actually tied directly to the data, so that you can then have different types of processing on it. That's how you can do multi-structured and unstructured processing and transformations in Hadoop. But what that means is while in a relational system, writes are slower, reads are very quick. While in Hadoop, writes are fast, because you can load a lot of information directly into Hadoop. And then then it really makes sense to use Hadoop when you're doing full scans or full processing across the entire data set that's split up across machines. And then the way Hadoop is architected, the way it gives you the parallelized performance is that it takes a process. So when you look at the processing row, it takes a job or a query that you wrote, and it distributes it across and pushes it to the data. So if you think of a data set you stored in Hadoop and it's split across multiple machines, you are taking a query, breaking it up into as many nodes that you have in your cluster. Let's say you have 10 nodes in a cluster. You're splitting it up into 10 pieces, and that's all being done by the Hadoop framework. And it's running in parallel, and then it's coming back and giving you the result. So the processing, the query is being pushed to where the data lives in the Hadoop cluster. In terms of data types that it's best suited for, relational and enterprise data warehouses are best for structured. Structured here means you have table-based schemas, you have foreign keys and constraints. And it's good because relational databases are optimized for that, right? They optimize for the compression. Everything that's done is optimized for normalizing the data and processing in that manner, while Hadoop is optimized for store in its raw form and process over it at once and use a parallelism to get your speed. And so with those different architectural trade-offs that are there in Hadoop versus traditional databases, you have different use cases that can be prescribed to either. So in the SQL Server and relational databases, interactive OLAP analytics, so the kind of application that I had written before where you are doing OLAP analysis on cubes of data where you have different dimensions and facts, that's really good in interactive where you want results quickly and you have a set of data that you control. It's not massive. That's good in a relational database. Or where you need to enforce complex ACID transactions and key indexes. Again, good use cases. While in Hadoop, people use it for looking through lots of log files, looking through and processing text information, and storing data at a very cost-effective way because it's easy to scale out. So we have now with HTTP for Windows and with SQL Server, we have this comprehensive data platform, right? That lets you store different types of information and processing and lets you make the choice between what's the right tool for the right job. With the Hadoop deployment choices, you also have, and I just want to kind of talk through the options here. There's HDInsight, which is the Azure service, runs in the cloud, and you can use that, and it has all the Hadoop functionality in there, and it's the benefit of Azure, elasticity, low cost. And then for your on-premise development and on-premise deployments, you have our HTTP for Windows, which is downloadable and installable on a multi-node cluster. You can get going with Hadoop running inside your data center on Windows Server 2008, 2012 instances. And no matter what choices you make, because it's the same core bits that are powering both, jobs that you write, queries that you write, different types of loading and data applications will work against both of them. And it's really cool. We're looking, part of the vision is getting to a place where you can have on-premise clusters, and then you can have in the cloud clusters. You can move data in between. You can use one as a backup DR scenario where you're DRing to the cloud and you're doing your main processing on-premise or vice versa. It's really, really exciting what kind of possibilities come because of this hybrid nature that we're working on, of working both in your data center as a cluster as well as in the cloud. So now let's talk more about the details of what components fit in and how it's actually architected to let you do all this different type of processing and move data in and out between the different systems. So at the core is HDFS and MapReduce. Let me start with HDFS. And again, if anyone has questions, feel free to stop and let me know, and I'll answer those questions. So the way Hadoop is architected, it's basically a distributed file system at its lowest level, which means when I store, let's say I have a 100-node cluster, and I store a file. That file will be broken up into different chunks. So let's say I have a 5 gig file I'm loading into Hadoop. It'll break it into chunks of 128 megabytes, and that value is configurable. What HDFS does is, behind the scenes, you don't have to worry about this as a user. It's storing that on different machines, so that even if 2 or 3 or 4 machines in your cluster were to die, because in general data center operations, machines die all the time, so you want to be protected against that. Those blocks will be striped across those 100 nodes in such a way where you won't lose data. Even if 4, 5, 10 nodes go down, there are 3 replicas of each block kept and split across the different racks in your data center, so that you'll be able to be protected up to some level of nodes going down at the same time. And all that's done on commodity hardware, which basically means you're buying workstation, you can buy general purpose machinery that can die because HDFS and MapReduce and the whole Hadoop platform has been designed to be resilient against individual nodes going down. So you store that information, and then once you have this file that's been split up across 100 nodes, when you can write querying processing, when you write jobs, that job will be split up into an equivalent amount of pieces and get pushed to those different nodes where the data is living. So if I had a job that was going through all my web logs and pulling out rows and sets of information that fit within one day, it would take that query, it would create 20 instances of it, and it would run it against one chunk of that file across different machines. So with that way, you are now running a query that's harnessing the power of 100 machines, running them individually, running each process in parallel on some part of those machines, and then aggregating the results. And that's how you can really take advantage of a distributed cluster with HDFS and MapReduce. And at its core, almost all the different loading of data and storing of data and processing happens with these paradigms. And so this is kind of the core base platform of the entire Hadoop stack. Any questions so far? Yes?
I was talking to Dan the other day, and he talked about storing the data into the blob storage. I guess can we talk about what that means for, we just talked about storing the HDFS.
Sure.
You said, storing blob storage. What is that?
It's a good question. So Azure has a blob storage called ASV, or Azure Blob Storage. And the way that this has been architected in Azure is that blob storage becomes the equivalent of HDFS. So in a cloud environment, blob storage, because of the way the cloud environment Azure is architected, blob storage is the more cost-effective way of storing data for long term. And so MapReduce can actually run processes against the blob store. So you can imagine replacing HDFS or complementing it with a blob store and telling your application to go directly against the blob store, do the splits, split up the processing the same way. So blob store becomes a cloud-optimized way of storing your data and enabling processing. So then that's a good question, because with this being a set of components, right, and all these different components come together to give you the full functionality, it's very flexible and very configurable. So you can configure different components to meet, if you're on a 5-node cluster, you configure it differently. If you're on a 20-node cluster, you configure it differently. If you're operating in the cloud, you can configure it differently. So it's a very flexible system. So before I get to this, MapReduce being a processing framework, you write code that defines what should happen on each of those different components, different pieces that I talked about. So if I'm running a process against different chunks of the file, you write code to say, what am I doing to that chunk and what am I returning? It's basically saying, what am I looking for and what am I passing on to the next stage? So you're writing code to do that. And I just want to kind of talk about how, as a developer, you would interact with the system. So Microsoft's actually developed a .NET Hadoop SDK that gives you the tools, gives you the classes, the interfaces to write this specific set of MapReduce programs in Visual Studio and run them against a Hadoop cluster. So what happens is you as a user, and this is the power of the way Hadoop's been architected, you don't care that you have 100 nodes that this thing's going to run on. You care you have one logical cluster. You're going to write a job, write a query, and submit it, and then the cluster itself will pick it up on one of its master services. There's always one entry point. We'll pick it up on, so for processing, for MapReduce, the master service is called the job tracker, for example. It'll pick it up and it'll run it across all the different machines. It'll handle parsing the query, pushing it to different nodes, and aggregating the result. So you as a developer will work in Visual Studio, develop your program, and submit it to the Hadoop cluster, and everything else will be taken care of by the Hadoop cluster. Now, so we talked about the developers and how they would interact with a MapReduce job. Let's talk about loading data. So we talked about HDFS, which is the scaling out file system, right, across many nodes. Just like you had one entry point for writing an application and submitting an application, you have one entry point for loading data into the system as well. So if you're loading multiple log files or files of any sort, you can use a RESTful API point to stream your data in and write to HDFS directly. You don't have to worry about hitting up different data nodes. All that parallelism is taken care of by this RESTful API. And so this is an example of a way to load data in from an application, from a command script, from a command prompt, from there's a Java RPC as well to load data in. But we see a lot of people use the RESTful API because this is, and then actually part of the Hadoop.NET framework, I think is available online from Microsoft, has code, .NET code that uses this API to load data into HDFS. So we talked about the core. We talked about MapReduce and HDFS. Now, remember in the diagram we had SQL Server, relational databases, and we had Hadoop next to each other, right? Scoop is a data egress, ingest framework that basically makes that collaboration and communication happen. Scoop is a framework that's called Scoop because it's SQL to Hadoop. So it lets you connect directly to a relational system. Could be SQL Server, could be any other relational database. And point to a table, and point to a set of tables and say, import into Hadoop. So when you're thinking of loading data into into a SQL Server and then pushing it out to Hadoop for batch analytics or historical analysis or different use cases, you can use Scoop to do that in parallel from SQL Server to Hadoop, and vice versa. If you have done analysis in Hadoop and you want to take that data set, result set, and move it back into SQL Server, you can use this as well to go from a Hadoop file back into SQL Server table. It's a nice, flexible, easy to use connector between SQL Server and Hadoop, as well as SQL Azure if you're working in the Azure environment. So we talked about data movement. We talked about the core. Now let's talk about, as a user, as an analyst, as a developer, how do you actually write queries, maybe not at the MapReduce level. So with a platform, there's different levels. There's MapReduce and Hadoop core, which is the base processing. You can write custom code. And then on top of it, there's a bunch of data services, the main ones being Hive and Pig. And what Hive does is it gives you, as a user, as a developer, as an analyst, a SQL-type interface on top of MapReduce. It's an abstraction. It lets you write SQL-like code. So you can write selects, you can do wheres, you can do counts, you can do a lot of different SQL constructs. And when you write that script, MapReduce and Hive will figure out how to take the query you gave it and break it into multiple pieces, or parallelize it, so then you can then run that against terabytes of data, split across the cluster. And what Hive does is, because it works with it provides you a SQL-like interface, it's a really good plugin for a lot of other tools. So Excel knows how to write SQL statements, right? You can do SQL-based statements through ODBC directly to a Hadoop cluster. So this is a good example of you as a user, again, not having to worry about what's going on in your Hadoop cluster. You're working with Excel, and you know which tables or which files in Hadoop you want to work against. You can, through an ODBC connection, submit queries and get results in Excel. And those queries will be operated at scale in the Hadoop cluster. And through ODBC, there's a lot of other Microsoft products, SQL Server integration services, reporting services that can be enabled as long as you can configure ODBC connection in your client application to talk directly to Hadoop.
You have a bunch of CSV files on the Hadoop cluster, and they're not consistent. Like they have a common key between the data and the files, but some of them have certain columns and others that don't have matching columns. Can you query all the files and pick off so a particular column is not on one of the files? Will it still review that and make sure, like will it go through that whole process of looking for the data?
So I think what you would do in that, so the question is, if you have a bunch of CSV files in Hadoop and they don't have the same schema, right? They have one will have a set of columns, the other will have one column but another set of columns. So in that case, people will write jobs that will, in a way, combine those files. So combine them into a common format. So one of your jobs could be join this table with this table, combine them, store the result set, and then run your analytics on that result set. So you can either do joins, which would help if you had those, and the way Hive works is that you store all the data that represents a table into one directory of files. And then you have another directory for that separate set of files that has a different schema, or slightly different schema. You do a join or you do an aggregation, and then you either query and analyze on that, or you store it in another directory and do your analysis on top of that.
So you have to understand the schema of each of the...
Yes. Yeah. Sure, the second question was you have to understand the schema of the file, of the data that's sitting in Hadoop. And this leads me to the next one, absolutely. So when you can load a lot of raw data and load a lot of data into Hadoop. And there are schema management, metadata management services available in Hadoop. And today what they do is they let you define schemas and point to a directory or a set of files and define a schema for it. And then it stores that and manages that, and it's available to the entire cluster, to all users of the cluster. You can assign different types of schemas to the same file. So you can define different types of formats where you want to combine two columns into one, you want to do different things. You don't have to change the raw data. You can just change the schema that's prescribed to the file. So you can have multiple schemas pointing to the same data set. Now, over time, what we'll do with this is that there's a lot of tools out there that do metadata discovery, metadata like guessing but predictions, right? This is the basis for that. This component, HCatalog is a component in Hadoop, in the Hortonworks data platform, that stores the metadata, manages the metadata, and over time will evolve it to guess the metadata, kind of extract it. And then some of that automated stuff will be possible within the parallel cluster. So if I were to kind of expand on that question, the steps here would be load the data in. When you're looking at doing querying, prescribe some schema to the file, to the directories. And then as you keep on loading data in, that schema stays on those files. So your query will keep processing as new data comes in, new files come in with the same set of schemas. It'll keep going, keep processing, and give you reports on that growing data set over time. Pig is another option that you have to write queries on top of data in Hadoop. So you have Hive, which is SQL-like. Pig is more of a scripting language that lets you do things like, I'll show you an example actually. Load data, create groups of it, do filters, do kind of group the data set and drop certain columns, do flattens, do hash maps, do more funky and cool things as a developer with the data. And you can define custom functions as well that you can apply. So a custom function here is not a bot. So basically, I think what it's doing is it's looking at the event data, the log data, and figuring out which rows are represented by an automatic bot and which ones aren't. And using HCatalog below, what you can do is you can access the metadata repository and not have to know which file you're looking at, or know what not have to define the schema of the file every time you run a query. You just hit the metadata repository, and then it gives you back the schema and lets you load the data and store the data. And so we talked about the core. We talked about how to write queries at the lowest level and the top. Yes?
In the beginning, you mentioned that .NET
Yes.
SDK that Microsoft has put together.
Yes.
Does that SDK provide same functionality as Pig and data language that you were using?
So the .NET SDK is basically using the APIs given by all these components, and just making it easy to do it from a .NET application. So submitting Hive jobs, submitting Pig jobs. So it's not replacing it, it's just making it easy to interact with it from a Visual Studio application.
There is some translation going on in the back?
There is invocation of the submitting of the job, submitting of the queries, and invoking and executing it, and then handling the result. It's more of a communication, starting, stopping, not a rewrite of the actual processing framework, if that makes sense. So the .NET SDK is kind of a helper framework that lets Visual Studio and .NET applications take advantage of this stuff without having to go directly and interact with the command line or other aspects. It's a way to make the developers' life easier to submit these jobs and run these jobs. And Uzi is basically a workflow framework which says, I have Pig jobs, I have Hive jobs, I have MapReduce jobs. I now want to define a workflow that says, run a Pig job, output. Take that output, put it into a Hive query, and then do a SQL analysis, SQL query, write that output so that then through Excel I can read the output. That workflow and scheduling it on a regular, repeatable basis is done through Uzi. So you can write these workflows. And that's the set of components that form the Hortonworks data platform that we have available for Windows. And this is the same set of components that exist in HDInsight as well. So now let me quickly go through some use cases. When we talk to clients, right, this is a generic platform. Sometimes it's hard to know where to start. What are the types of things I can do with it? So for the most part, when we go to clients, we really see this operational data refinery use case resonating the most. It's another way to think of it is modernizing ETL. Basically saying, instead of having to know when I do my ETL and I do extracts and I get data from different sources, I have to prescribe a schema and then load it, ETL. This is saying, instead of that, to incorporate the news sources, incorporate different things that don't really go very well through that extract process outside the data platform, let's just load it in the form that it's in. Let's do an extract, load, and then do a transform in the system. And so an example of that is we were talking to a bank who stores a lot of legacy ATM transaction information in mainframes. And they're stored as very specific file outputs from that mainframe. And so what this company wanted to do was take that data, load it directly in Hadoop. And there's a few reasons we want to load it directly in Hadoop. One, they need to do the transformations of taking that and transforming it to become a more readable, consumable format by their relational systems, SQL Server in this case. And so you would take this new form that's been hard to process, hard to manage, store it in Hadoop directly as files, do your transformations using Hive or Pig script, and then push it out to SQL Server where they can then power their reports and business analytics. Another benefit they found from using Hadoop is that because they're a bank, they had this financial regulation where they had to store those exact mainframe outputs in the form that they existed from the mainframe for years. And so they actually had to keep a raw copy of that data. And Hadoop and HDFS being this very cost-effective mechanism to scale, because you can just add a node, keep adding individual nodes horizontally to the cluster, and it'll just rebalance and keep adding to your cluster. It's very easy to start off with a certain set of data and keep that growing over time. So for a few different reasons, we're seeing people use Hadoop and HDFS and the processing system as kind of a data repository or data lake where they're just capturing all the information, all the data that they have from from their OLTP systems, from their web interfaces, from different types of systems, and then doing transformations in Hadoop. And then pushing out that transform refine data into SQL Server where they do interesting OLAP analysis and reports and self-service BI and those different types of things. Another use case that we see is exploration and visualization. So what I talked about before was kind of taking data and transforming it and using Hadoop as a transformation layer. This is using Hadoop as an exploration layer. Saying so one of the customers I can think of is a device manufacturer who manufactures devices for home users all over the world. So they have lots of millions of customers. Those customers often want to file support claims or support forms or talk to their customer support people. And they fill out forms online describing in detail what's going on with the hardware that they bought. Those forms are valuable sets of data that really wasn't being used and analyzed because it's kind of expensive to do that. So they use Hadoop to store all those text forms, use it to do searches, indexes, find keywords, find patterns of all the different customer service forms, and at the same time do that while pulling in their customer CRM databases, pull in their web interactions all into Hadoop from SQL Server and other relational databases, and do that transformation analysis of what's going on with the customer, what are they seeing, and what specific information can I get to know about them, about the types of support claims that they're making. And exploring the different support forms to look for patterns, doing that directly in Hadoop, maybe with Excel, and I'll show you kind of a demo of how you can do exploration in Excel with Hadoop. And then the third one is application enrichment. So this is an example where I have models that I'm creating. So if I go back to my favorite use case and favorite application, the marketing analytics application. What we were doing is we were taking historical sales and historical marketing information and using that to create a model to predict future success, future trends if I change my marketing spend. We did that on an aggregated level because we couldn't afford to create the models on a very granular level. Now with Hadoop, I can keep loading in the granular events that happen every single day and rerun my model, because it all happens in parallel format in Hadoop, and update that model on a daily basis, feed the model into SQL Server, and run my OLAP analysis against that model, run the prediction forecasts in parallel data warehouse or in SQL Server. So Hadoop becomes this way to quickly update your complex models by incorporating data on a regular basis, rerunning your models, and then using an online application that's actually running the models against the new updated data. So instead of months that it took for us to redo the models, you can do it in days now, and that's what some of the web companies do. And these kind of use cases, these kind of examples are really across all sorts of industries, all sorts of Fortune 500 companies we talk to. And so when you break it into refine, explore, enrich, it kind of helps you understand how something like a parallel, unstructured data storage and processing infrastructure can really help add value as an addition to a SQL Server and parallel data warehouse. It's part of this comprehensive data platform. Now let's go through a quick demo. I think I have 10, 11 minutes left. So what we'll do is we'll kind of go through a refined use case. This is a use case where I have user information, product information, and I have web clickstream information. And I want to take advantage of the web clickstream information, kind of explore and analyze it, and run a query where it combine it with my product information, geography information about my customers, so I can see that more consolidated view and use Hadoop to do that. So what I have here is we have a machine with the Hortonworks data platform for Windows installed. So you can see that it's installed in the programs and features files here. And what it means to be installed is that, to go into details, it actually sets up all the different components. You can see here that HTTP is formed of Uzi, Scoop, Hadoop, and it sets them all as services. So your Windows Server box now has all these services registered that represents the Hortonworks data platform installed natively on Windows Server. Now what I do is I load in the files through WebHDFS or some loading framework, and now I have my user logs, my web clickstream logs, stored in Hadoop. You can see it in the list command that the file is actually directly stored in Hadoop, So what I'm going to do is I'm going to actually want to explore it and see what's in there. I'm going to load up Excel, go to Data Explorer, and do a query and look for the data against HDFS. So I put in the server that's running, the one server that's running the entry point to Hadoop. And Data Explorer goes through and actually finds all the files in Hadoop. And so this is Excel talking directly to Hadoop and HDFS. And you see logs.tsv. That's my logs file. That's what it was loaded in before. So now you're going to use Excel and Data Explorer in Excel to interact directly with this distributed data system and look at the data in logs. And here what I do is I use the functionality in Data Explorer to say, great, I have this unstructured log file. Help me understand what's in there. Help me figure out, explore the value in it. So what Data Explorer is doing is kind of looking through the different delimiters in the format of that file and extracting it out in the easy-to-view page where I can now look at the different types of data in that file. So here I have all the different columns, all the different raw data that is collected as part of my application server web application framework. And I don't care about some of these things, right? So I'm going to say, I don't really care about the first column. I care about the timestamp. So I'm going to mark that. And I'm going to care about a few other things like URL and other things. So I'll do all that in Data Explorer. And then once I do that, I get something like this. I basically get a refined view of the raw data that's sitting in Hadoop, in HDFS. I can do things like, let's look for one IP address and see how many times they visited my site. I filter for one IP address, and I see that this IP address only came to my site one day, on March 12th, and did a lot of different things there. So this is a way to explore the data in Hadoop through Excel. And what I've also done is I've loaded in Hadoop product information and user information. So I have all this information that I need for my analysis all in Hadoop at the same time. And why that's important, why that's useful, is because now I can run a Hive query that combines all these pieces of information that I got from different places and run it in parallel in Hadoop. And so I have a query here. It's going to basically create a combined web log analytics table that combines the different data sets, all sitting in Hadoop at scale, and helps me understand a complete view of my customer across these different dimensions. When I run that query, I get this as an output in Hadoop, and I pull it into Excel. It's basically log, URL, IP address, all this information about a customer, and information that was really stored at a very large amounts of scale, all into Excel. And then when I do it in Excel, what I can do is I can create things like charts. I can now turn that raw data into insights, right? I can do things like tell me all the groupings of where the unique visitors came across the country. So I see California, San Francisco area, New York, Texas. I'm gone from this raw log data to insights in Excel pretty quickly. And then I can do other things like that. In the same set of data that I combined, I can compare the types of categories that were shopped for and unique visitors that came that day. So do comparisons against the same types of information and see that there's not really a correlation between the unique visitors and the types of products that are being bought and the ratio of products being bought. So this is an example of using Hadoop to do distributed processing and to really pull in different types of information all in one place. So you can do this transformational analytics to combine it and then directly from Hadoop show that value in Excel to your end users. And that's, any questions? Yes?
Can you still use the Java MapReduce jobs within HDInsight, or was it HTTP?
No, you can actually write .NET applications from MapReduce.
You have existing Java MapReduce jobs. Can you use those as well?
Yes, absolutely. So you can do, people do Java, .NET, Python, Perl, all kinds of applications. It's an interface that lets you do different types of application programming languages for MapReduce. Yes?
So you've mentioned a couple of unstructured data, but they're not that unstructured. CSV files, forms. What about pure text files?
Sure. So you would then write your custom applications, custom MapReduce jobs to look through. So what it does is you'll define how you want to break it up. You can do a stream of bytes is your record. And you can look through those records and find patterns and create more structured data and then power the reporting that I showed here. So when it comes to unstructured data like that, you would write a custom job that would look for the type of or process in the way you want to do it. So Hadoop is a framework that lets you run it at scale, and then it lets you write your own custom application logic, write query logic, and Hadoop just takes care of running it, making sure it runs across the entire data set, fault tolerance, and all that functionality. So it's a good question. So for types of information that are more unstructured and need more massaging, it lets you write your own logic to do that. It just does it at scale. Yes?
Is there any way to put some sort of structure on top of those files, like define a collection or a like group of files, like emails, and then your analyst output? That sort of thing?
So there's different ways. Some people will organize them in directories and run a job. And so when you do organize them in directories, you can run a job that runs against all the files in that directory. And so that's how you can organize some of those files. The transformations that people do in Hadoop take those raw files and create more organized schema-ish outputs. So it's kind of a multi-step iteration. It's happening on, let's say, many terabytes of raw data. You create more manageable, aggregated views or organized views of that data. And so you can do MapReduce jobs that take that raw data, output more structured key values or CSV or delimited files. Yes?
Example that you had with a log file.
Mm-hmm.
So the idea would be that if I had a couple of years worth of log files, I would dump them into one directory on Hadoop and still run the same sort of example that you ran.
Yep.
And it's supposed to be just minutes worth of processing, not hours of processing that you would see on a RD.
Correct. Correct, yes, because it's splitting it up and running that same process across multiple pieces. And there's ways of tuning that. You can use one directory, parent directory, but Hive has partitions. So if you run a query where you do where clause that only wants certain days, you can actually store your data in directories that are partitioned by date or a certain column. And so you can optimize it too to get more and more performance out of it. But the idea is completely correct, where you're loading all this information in, and you're running this process in parallel, where even if you grow out to be 200 days or 400, 600 days of information, you can either scale up your infrastructure or just use the infrastructure to run this much faster than would be even possible in some of the single or small clustered databases. Yep. Okay. Thank you. Yeah,